we learned that you could take a sinusoidal function, and the basic one is drawn right here for you. So this is the standard one. And you can do certain things to it. So you could take it and you could move it up, or you could move it down. You could also move it to the left, to the right. And you could also, and I don't know a beautiful way of doing it, stretch it. So you could take it and you could pull it so it's stretched up, or you could compress it so it's stretched down, or you could also pull it so it's stretched wide, or compress it so it's kind of crunched down. We also learned that to do those things, you needed 4 different variables. So there's the A variable, the B variable, the C variable, and the D variable. We're just going to remember what each one of those things does. Right? The A variable. Let's write this on top. The A variable is also known as the amplitude. So if the A variable changes, it's usually 1. If it changes, it also changes the amplitude, which means that it's changing the distance between the top and the midpoint. And that in there, that's A. By doing that, you're doing a vertical stretch, VS. If you want to actually write out vertical stretch, that's fine. Which makes sense because you're changing the amplitude. You're separating the top from the middle further or getting it closer together. The B variable is not the period. It affects the period. Okay, let's make that very clear. The B variable is not the period. It affects the period. So affects period. A bigger B value means a smaller period. A smaller B variable means a bigger. When we talk about how it's affecting something, if it's changing the period, that means it's taking this graph and it's changing the distance from when it repeats itself. So that's the period. So the B variable would be a horizontal stretch, right? It's either stretching that period out further or it's compressing it in. So we say it's a HS, horizontal stretch. The C variable. The C variable moves things left or right. Okay, so it'll take your standard graph and it'll shift it to the left. Or it'll take your standard graph and it'll shift it to the right. So C variable is a horizontal, I put BS for vertical stretch, HS for horizontal stretch. So I'm going to say this thing's a horizontal translation. The other word they could use is shift. Remember that you've probably heard that, like a horizontal shift, so it's left to right. It's kind of hard to figure out horizontal shifts, just to be honest. In your graph, what I like to check to see if horizontal shifts have happened is I like to see the starting point and where it's gone to. So the starting point on the regular graph is always at 0, 0, and it's always at the very middle of the graph. So if that starting point is moved somewhere, I assume it's a horizontal shift. The D variable. The D variable does the midline. So that is taking that middle line in the graph, which is, in our case, always on the x-axis to start, and it moves that thing up or down. So we would say the overall graph is doing vertical shift. I can't fit the word translation. You could also call it a translation. Alright, that's what all those variables do. Let's see if we can actually calculate them by looking at a graph. So, your standard graph is shown. I'll draw it again in red. This is your standard graph. They're saying that it has been changed into this form. So it went from y equals sine x to y equals a sine bx plus c plus d. So it has been altered. Your job is to figure out what a, b, c, and d all are. Let's start with a. So if you want to figure out what a is equal to, what are you going to try to calculate on the new graph? The amplitude. Yeah, exactly. A means amplitude. So if you want to figure out what the A value is, you need to figure out the amplitude of your new graph. The amplitude is the distance from the top to the midline. Or it's the top to the bottom divided by 2. Right? So either way. I think some people are really liking that formula. Max minus min divided by 2. So if you use that formula, my max appears to be at 3, my minimum appears to be at -6. So that means my A value will be 3 minus -6 divided by 2. That means A equals 4.5. Sound good? Any questions on amplitude? Feeling good? All right. Let's try our B variable. So in this equation, we want to figure what B equals. There was a formula for B as well. It's not equal to the period, but it affects the period. Your B variable equals your 2 pi divided by period. That formula is kind of given to you. The formula you get is period equals 2 pi divided by b. You could rearrange it to get this formula. All right, if I want to figure out what that is then, so b equals 2 pi divided by, what's the period of this graph? How long does it take to repeat itself? We're talking about the thick line here. It repeats itself starting here, which would be 2 pi. So b value would be 2 pi divided by 2 pi. Your b variable is equal to 1.
So why would it start to repeat there and not
Not here?
Yeah.
You don't, like, a minimum would only be repeating at another minimum point. And you don't see any other minimum points, right? Like, the maximum and the minimum, it's coming down, but then it's going up. So it's not repeating, it's opposite. Yeah. Good? Alright, your C variable. So your C variable is what's making your graph shift left or right. To figure that out, it's kind of tricky, and it takes kind of some intuition, in my opinion. So I'll do it right here. So if you look at your original graph, and you look at your new graph, and you try to find some points that like correspond to each other. So for instance, I'm going to check my starting point right there, my first x-intercept. The only way that that x-intercept is going to move off of the 0, 0 line is if there was a horizontal shift or a vertical shift. Where's that new line, that point on the old graph? It's right here. See how those points correspond with each other? It has not moved to left or right. It's moved down 2, but it never moved left or right. So that means your C value equals 0. That point has not moved. It stayed exactly where it was. But your D value made it move downwards. That's why it's moved down. But you're checking, when you're doing your C value, you're checking to see if it's moved left or right. And it hasn't. Does that make sense? C value is left or right. It has not moved left or right. It equals 0.
So then D would be -2?
D would equal -2, but I think there's a better way to find that variable, or that value. And to find your D, you remember it's your midline. So you try to find where the midline is on your graph. Your midline is right here at -2.
In this time it says the midline.
That's a good question.
Or equation of
Oh, y equals -2. So if you wanted to write your midline equation, it'd be y equals -2. I was like, ooh, formula. I don't know a formula for that. I could probably try to make one up, but that's probably risky.
And then we'll take
Yeah. So if you looked at this thing, if you want to know the domain and range, the x values are going to go forever. The range, though, the highest it would ever go is right here, and the lowest it would ever go is -6. So your range would be in between -6 and +3. So if you didn't want to do the range, you could. All right, this question. Give it a shot on your own. See which variables you can think of. So see if you can figure out what A is. See if you can figure out what B is. See if you can figure out what C is. See if you can figure out what D is. First thing that's important is figure out what your scale is. Your x scale and your y scale. Your y's are going up by 1, so they're easy. The x scale is not easy. The way I figured it out is I noticed that they labeled a point here. They labeled that point as pi. This point is 0. That means from 0 to pi, they've divvied it up into a certain number of squares, right? So they've got 1, 2, 3, 4, 5 things. That means each jump must be pi over 5. Who's going to have pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5, 5 pi over 5, which is just pi. That makes sense? So each block would be 1/5 of a pi. So from here to here is pi, and they've broken up into 5 sections. That's 1/5 of a pi every time you go a section, which is just pi over 5. I'm blowing you on it. Yeah, so here's like, yeah, no, a whole bunch of it is like mind-boggling. Think of it like you've been doing this, but with easier numbers, and that's probably why it's like mind-boggling, because we're using pi instead of regular numbers. If I give you a graph, and I said, okay, here it is, here's 1 point, it's 10, and then I broke it up into other points. How would you figure out how much each one is? 2, 4, 6, 8, 10. What you really did was 10 divided by the 5 sections that are in. 10 divided by 5 is 2. You just counted 2 5 times to get to 10. So that's exactly what you've done here, is it took you pi to get all the way here. So each one of these has to be 1/5 of that. Like each jump is 1/5 of the way there. Kind of crazy. It takes some practice, and you're going to get some practice with it because they usually do graphs with weird scales. Normally they do pi over 6, just so you know. But if you're confused, just take the first point they give you, divide it by however many sections there are. Yeah, Jake.
So after, once you get to 1 pi, say like, what would like the middle, I don't understand, like, how would you label it after first pi?
So if I want to know what this tick was,
Yeah.
so I would have 1 pi, 2 pi, 3 pi, 4 pi, 5 pi over 5. This would be 6 pi over 5. And you literally just keep counting up 7 pi over 5, 8 pi over 5, 9 pi over 5. That's 10 pi over 5, which simplifies to be 2 pi. So every single jump you're doing is just, you're adding 1 to the top. Because you're adding one more fifth onto it.
Could you make it 1 and 1/5 pi?
Yeah, I mean, it says 6 pi over 5. You could, yeah. We don't do a lot with scales like this, so don't be too scared about it. But if you just take the first thing and divide it by the number of sections, that'll tell you what it is. Alright. So each jump is a pi over 5. Next thing, let's start actually figuring out variables. So A, what's A also equal to?
Max minus min divided by 2.
Max minus min divided by 2, or the amplitude, which is the distance from the top to the middle. The distance hasn't changed on this thing. So the amplitude hasn't changed, so it's equal to 1. You'll notice my high and my low are still the exact same distance away as the original graph. The period's the hard one, and the C variable is the hard one.
How's the amplitude not 3 though? Because you take the min and the max, which is 1 and negative 2.
That's negative.
1 positive.
That'd be why. Honest. The next thing you do is you try to figure out your B variable. And there is a formula for it, right? So B equals 2 pi divided by whatever your new period is. And you got to figure out what your new period is, which is hard on this graph. It's not easy. It doesn't stick out nicely. So what you need to do is find 2 points that are easily labeled. I'm going to say this point and this point. And those points are the same point because that's when it starts to repeat again, right? It goes down, up, down, and then it starts over again. So that would be the exact same graph. If you do it in another color, down, up, down, and you see that those graphs are the exact same. Right? That's when it starts to repeat itself. Everybody see that those points repeat themselves there? It's tricky. I use my maximum points or my x-intercepts usually to find things that start repeating themselves, because they're easy to identify. The reason I'm using my x-intercepts on this question is because the x-intercepts cross at perfect points, where my maximums kind of seemed a little bit off for some reason, but they would have worked too if you just kind of rounded it up a little bit. What I do is figure out how long is it taking me to repeat. So if each little spot is 1 pi over 5, it would be 1 pi over 5, 2 pi over 5, it would be 3 pi over 5 to start repeating. That's my period. That's where I came up with 2 pi divided by 3 pi over 5. You could put that in your calculator and math bracket to get 10 over 3, or you could remember, I'll write it over here, but you could rewrite that fraction and say it's 2 pi over 1 divided by, what is 3 pi over 5? And you could do it by hand if you wanted to. Right? So this is the 2 pi divided by 3 pi over 5. You could kiss and flip it. Yeah. Yeah. Again, you can put your calculator too. Just use brackets so you know that the 3 pi over 5 is together. You get it or you don't get it? You get it? Your C variable. Your C variable is tricky, and there's actually 2 answers to your C variable. So, what I did was I took my original x-intercept right at the origin. That thing goes up. And I found the first time I found an x-intercept that goes up. So the first time on my new graph that happens is right here. And I tried to figure out how far that had shifted to the right to get to the new point of my first x-intercept going up. I had to estimate that it's actually 3 pi over 5 because it doesn't land perfectly on.
Wait, how do you know that it shifts? Because in the other one, didn't we just compare the two where it starts?
Yep, so that's where it would have started, but see how it shifted to the right? See, this is the first x-intercept that goes up, so that's the starting point.
Oh,
So I'm trying to find another x-intercept that goes up. Yeah, it has to be an x-intercept that goes up. The reason being, so the reason why you have to check those points, is every other point on this graph is affected by a stretch. But 0, 0 would not be affected by any of the stretches. If you tried to stretch 0, 0, 10 away from that, it would still be stuck there because 10 times 0 is still 0. And so that's why the 0, 0 point is good for checking how far I've shifted left or right. It's your first x-intercept that goes up.
So your first x that goes up is the starting point?
Yeah. Now, the reason I said there's two answers to this is if I kept drawing this graph, you would have had another x-intercept that goes up. So you could have said, instead of going 3 pi to the right, you could have done 1 pi over 5 to the left. Right? So sometimes on graphs, there's two answers, like if they drew the graph completely for you.
And on the other one, it was the new, when we drew the new line, like the old line, RC was 0. So then why over here are we, would our RC be alpha?
And not right here?
But yeah, why would it not be 0?
That's a good
and then
question.
This side we're counting it as 0.
I think the reason it's confusing is because your d value in this one is 0, like it didn't move. Where in this one, our d variable pushed this thing down, so we knew that it was going to be our x-intercept, but 2 down from it.
Okay, so which one do you?
I always, if I was to calculate this in order, I would calculate my midline first, so that you know if it went up or down.
I mean, like, which, for your C, so, yeah, it was your second point when it starts to go up is the pi over 5, right? Or 3 pi over 5, right?
Yep.
So then you ignore the other two, you only do the new line? So I mean,
Yeah. You're only checking the new line.
okay,
Yeah, you're not doing the other one. Yeah. That one's just always 0.
so then the other one's 0 because it's before it?
Because t is, like, this one's 0 or this
Yeah.
one? First one? Yeah. This one's 0 because the midline pushed it down, but the y-intercept, like this thing here, stayed, you can tell it's the same starting point. It's just been pushed down from the d value. As this one, the midline is still right here, which is why we were able to check that first x-intercept point to see where it goes up again. Because the only way that thing could have moved is if it was shifted left or right. The only way this one moved is because it was shifted down. These are hard. They are hard. We don't, just so you know, we don't do a lot of these. What we do more of is word problems in this class, which actually are easy. I think this stuff's hard. The word problems actually are quite, like, if you're good with your calculator, they can be quite easy. Yeah. You may have. Yeah. Both of you guys, right? Coincidence. All right. The formulas for all that are right here. So if you're trying to figure out horizontal phase shifts and stuff like that, it's all there. This is just a review of everything that we just did. We're going to do a couple word problems, and then I'm going to leave you to do a couple on your own. Plus, there's some in your note package. The good thing about these word problems, one, they're almost always going to give you A, B, C, and D. And that's kind of nice. Two, they don't use like pi. It's pretty rare that you see something like 2 pi over this. They just put in crappy decimals most of the time, or even whole numbers sometimes. So you don't need to worry so much about your scale being in a radian mode with the 2 pi over 5 and the pi over 6 and all that stuff. That stuff is more 30-1, and you do a lot more of that stuff with 30-1. For sinusoidals in this class, we do a lot of word problems. So if we were to read this one, it says the function provided estimates the average monthly temperature of a northern Alberta community, where T is the temperature in degrees Celsius and X is the month of the year, such that the entire month of January has elapsed at X equals 1. The entire month of February has elapsed at X equals 2, so on and so forth. So March would be 3, April would be 4, and so on and so forth. When I do word problems, I like to read them once, be like, what's going on? And then read them again and try to draw any info that matters. So the first thing I did is I read it and I realized that this equation is telling me something about temperature in a city in Canada. If I was to read it again, I would say T equals temperature, X equals the month number. Like, that's important. Just writing out what things mean really helps you. The next thing I do is try to answer some of these questions. So it says, graph this equation, what's an appropriate window? So we're going to pull out our calculators, and we're going to try graphing this thing. So we're going to type this in. Make sure you are in radian mode. Remember that? So your mode must be radian mode for this stuff. I'm going to type in here 23.58 sine 0.51x minus 1.79, close bracket, plus 2.341. It looks exactly the same as how they have it in here. That's not anything crazy. In my y equals, yeah.
Window.
Oh god. My calculator's doing crazy things. We're going to talk about window in a second. Okay. Everyone should have that typed in. Don't try graphing yet. We're going to set a window together. Because the window is what makes these questions usually hard. If you did it yourself, that's fine. But my suggestion is that you just wait a minute. So, that should be typed in. Go to window. What we're going to do is we're going to set x min and an x max, a y min, and a y max.
With the extra speed.
That makes sense for this question. Okay, that's the key, is put in context the question that's happening. For x, what does x represent in this question? The number of months that have passed. What's the least number of months? Well, you could have 0 months, so no time has passed. It's like the first day of January. So x minimum, 0 would make sense. No months have passed by. X maximum, 12. That would be 1 full year. If you wanted to see 2 full years, you could put in 24, right? But there's 12 months in a year, so x max of 12 just kind of makes sense. For your y minimum, what did y represent in our question again? Y was temperature. So, what is a low temperature for a northern Alberta community?
Minus 30.
Negative 40, negative 30, somewhere in that range should work for us, right? So I'm going to put in minus 40. I could be way off. That could be too much. But at least it's in the realm of possibilities. I'm not going to put minus 1,000 in there because that's Edmonton. Y maximum. What's the highest temperature you think you're going to get? Yeah, 40, it would be a super hot day. Maybe you do 30 again, same like the minimum, right? That's in the realm of possibilities. If you got up to 40, like, hey, that's a super hot day. It might be too much. We can adjust later. But what we're doing is we're creating a window that's reasonable to the situation so that when I hit graph, I should be able to see something. And when I do that with this window, it works out actually really nicely. It works out almost perfectly. I've gone a little too low, a little too high, but that's okay because I can see everything that's happening in my graph. So you should have x minimum 0, x maximum 12, y minimum negative 40, y maximum 40. Yeah. For sure. Your graph should have looked something like this. I'll sketch it to the best of my ability. You want to go below that. And if you were to make, nope, it doesn't go that far down, like that. Just like that. Yep. If you were to look at this graph, you should be able to look at it and interpret what's happening. So, y is my temperature. X is my... I started with the month of January. So it makes sense that my temperature is low. Also makes sense that this thing would go up as time went on until I hit about August, and then it comes back down. And if I was to extend that graph further, guess what it would keep doing? It would just keep repeating. It would make a sinusoidal graph, which is why these graphs are actually useful, because a lot of things can be trended like that, where it's a wave. Like And over time, it's going to keep happening kind of the same, give or take a little bit. So that's what this graph represents. In the question, there's a whole bunch in here. So it says, what is the warmest month? What about the coldest month? So if you wanted to figure out the warmest month, you want to figure out this point right here. That would be the maximum. So you would go second trace max. You would go just left of that point. You would go just right of that point. And you get an answer of 6.59, comma, 25. What that means, 6.59 needs to round, first off. So we would say the 7th month would be the warmest month. So January, February, March, April, May, June, July is the warmest month of the year in this city. Just for fun, what does the 25.9 represent? That would be the temperature at 6.59 months. So the warmest that it gets on average would be 25.9 degrees, and that would be over halfway through June. We rounded it to July. Right? June was month 6, July is month 7. We're 0.59 of the way through the month of June when we get that temperature. Logically, does that make sense? Yeah. Also important to check that. If I ask you what the warmest month is in Edmonton and you answer with January, you made a mistake somewhere in your calculator. Okay? Like usually your answers will be logical answers. Pardon? Yeah. It depends. Okay. Coldest month. That would be your minimum, which is over there. You can go off your chart a little bit. So when you go second trace minimum, and you can move your cursor, you can move it off your page, and that's fine, because you need to get left of that minimum point. So if you want to be sure you're left of it, like go past it a bit off your page. You could also just change your X minimum value so you can see further left. It like shifts your graph. Yeah, it'll like move it over for you. It's kind of cool. So left bound, right bound, hit enter. That is at 0.42, comma, negative 21. 0.42 represents the month, which would be December, right? January is month 1, like the whole thing is done. So we would say December is the coldest month, or partway into January, like the first couple of weeks of January. And the temperature would have been minus 21.2. Logically, does it make sense that December could be the coldest? Definitely. Is the possible coldest temperature minus 21? Yeah, that's realistic. Like, that is possible. All right, C. What is the average temperature in this community? They're talking year long. That would be your midline. That's what it is. So your midline is going to be somewhere in, let's just roughly estimated, middle here. Your midline would do that. Does your calculator have a midline button? Sadly, it does not have a midline button. Right. But you learned something about midline. Your D is your midline. So if you look at your equation, where's your midline going to be? 2.345. That's your midline. So the average temperature is at 2.345. That's your midline. So when they ask you average of something, in this case it was average temperature. This only works for Y values. If they're asking you your average month, I have no idea how you do that. But if they're asking you what's your average Y value, it makes a lot more sense. I'm not going to ask you what's your average month in this community. That's kind of crazy. But if you want to know what's your average temperature, that makes sense. It'll be your midline. Because half the time you're above it, evenly distributed with half the time below it evenly distributed. So it's even out to be in that middle, which is your p-value.
It seems to drag out.
Yeah. D. What is the period of this function? The period of this function, you're going to have to figure out when this graph repeats itself. So to do that, you have a few options. You could figure out the distance between your x-intercepts that both go up. You could figure out the distance between maximums, that would also work. Or distance between minimums, that would also work. The problem with all those solutions is, on this, our current graph, you can't see two maximums or two minimums or two x-intercepts that go the same way. So what you need to do is make your graph a little bit bigger. So change your x max to like 24, so it's 2 years. And what you should be able to see is at least two maximums. Now when I change it to 24, I can see two maximums. And I'm going to figure out, so my graph now looks like this. And it goes up, down, like that. Your graph should look somewhat like that as well. You should be able to see two maximums now. Figure out the distance between those two maximums. And that'll tell you your period. That'll tell you when it starts to repeat again. So, if we did that, we could go second trace, maximum. We already know this maximum is 6.59. So I just need to find my other maximum, which is going to happen at 18.909. That's my other x value maximum. So that's this point right here. You want to figure out the distance between them, then you subtract. So subtract 6.59. And that'll tell you your period, how often they repeat each other. So if we did that, we go 18.9098 minus 6.59, and you get 12.319. Does it make sense that your temperature would restart after 12 months roughly? Yeah, that makes a lot of sense, because that's exactly what would happen in real life. Your trend would start again every January, right? It would reset.
So you only have to find it for the x value, subtract the x value, not the...
Only x value. If you subtract the y values are the exact same because they're the same height. They're both maximums. Is there another way that we could have done this? Yeah, what is it? The period equation. So that's one way to do it, is to read your graph and utilize it and just understand it's the distance. The other way to do it is period equals 2 pi divided by b. Has b been given to you in your equation? It's right here. 2 pi divided by 0.51 equals 12.319 or something like that. We rounded, so like the fourth decimal changes or something like that.
Where's the
The pi button is second, and then right above the division symbol. Either method works. So you could have done 2 pi divided by b, which is 2 pi, that's a b, not a 6. Yeah, sorry. Which is 0.51, which equals the same thing. I mean, it's slightly different, but that's because we rounded earlier, right?
If your value is negative, do 2 pi divided by negative 0.51.
You would do the positive value of b. Good question. Yeah. So if the b value, like, if the b value was negative 0.51, I would do the positive 0.51.
Just get rid of it.
Yeah, just get rid of them. Yeah, just drop that. That, way more typical of the type of question you get on a diploma when it comes to sinusoidal functions. You need to understand what all these things are and what they do to your graph. A lot more than you're going to have to find them. hard to find them. Good skill to learn, hard to do. Not really that crazy necessary. All right, let's rip through another one. There's a bunch here, so there's 2 more after this that I want you to try out. This thing is talking about the sunrise. Again, if you think about it, the sun would follow a sinusoidal function. It goes up, down, up, down, up, down. Follows a perfect sinusoidal trend. Other things that follow trends that are sinusoidal. Wheels on a car, right? A Ferris wheel is another typical one. Anything that's going to keep repeating itself will be a sinusoidal function. Kind of like me repeating myself all the time, which I do. All right. This thing says the time of sunrise in American City is given by the equation. It's given you there. Where N is the nth day of the year and T is the time after midnight in hours. I read it once, just to understand what it's about. I read it a second time so I can draw info out of it. They're talking about the sun rising in America. I read it again. The time of a sunrise in Maritime City is given by this equation where N is the nth day. So N equals day. And T equals time in hours. So I'm going to say hour of day. It does tell you after midnight. So midnight would be hour 0, so it would basically be like a 24-hour clock. 1 would be 1 a.m., 2 would be 2 a.m., 12 would be noon, 13 would be 1 in the afternoon. It's a 24-hour clock. Graph this function, what's an appropriate window? I want you to try it, so give it a shot, see if you can graph it. You come up with a minimum maximum that seems reasonable to you. And I'll put up my minimum maximum that's reasonable to me in my minimum max. So, I went to graph my function. To graph this function, I had to come up with reasonable x min and x max. What does x represent in my question? X is n, which is the day of the year. What's the least number of days in the year you could have? If the first day of the year would be day 0, or day 1, whichever way you want to look at it, would be fine. And that would be January 1st. So I would say 0 would be the minimum number of days that could have passed in a year. What's the most number of days that could have passed in a year? My x max, 365. So I'm saying this represents a whole year. From the first day of the year, January 1st, to the last day of the year, December 31st. The trickier part is the y min and y max. And if you notice, I put 0 and 24 at the start because I made a mistake thinking of what t was. So, what does y represent in our question? The hour of the day that the sun rises. If you had put 0 and 24 like I did, it works. It's very stretched out, but it does work. If you're considering y values of just when the sun rises, I'm not going to consider the sun rising at midnight. Not reasonable. If I'm thinking the earliest that the sun ever rises, it's early in the Maritimes. I know that. I'm going to say like 4 a.m. And I know that's probably a little too early, but that's okay. I know for sure the sun will be risen by 4 a.m. What's the latest that the sun can rise? I'm going to say 9 a.m. So in the winter, it takes a while for the sun to come up. That's reasonable. If the sun doesn't come up by 9, that's like kind of sucks.
Close.
Yeah. If you put that in, your graph should look like this. And it doesn't actually look like that. That represents the time the sun rises depending on what day of the year it is. That's what your graph should look like. All right. What day does the sun rise the earliest? So on this graph, you would be looking for a minimum point down here. I feel like this graph should have a negative sign right here to make this graph more realistic. So this graph actually isn't realistic. If you think it's realistic in the sense that it's sometimes of the year it rises early and sometimes the year rises late. It's not realistic in the sense of how they have it. Because our first day of the year is January. That's when it should actually rise the latest. Right? Think about when the sun rises. In the winter it rises late. In the summer it rises early. So this graph's actually upside down on what would make common, like make actual sense. So it should be, the way that they can fix that, and I'll fix it later, is if you put a negative in front of there, that would flip the graph and make it a lot more realistic. But that's okay. So, according to this, what day does the sun rise the earliest? You need to find that minimum point, and that'll tell you the day that it rises the earliest. So again, you need to go off your graph a little bit, and that's okay. And you can find either minimum point that would work, but it would be kind of weird to talk about the 360th day. So I would go past it a little bit. And I find that my minimum is at negative 11 here. If I came all the way out here and found my minimum point out there, it would probably be 365 minus 11, be 354. In the context of the question, you could say it's the 11th day before New Year's, so before January 1st, so go back 11 days. Or you go forward 354 days. Because we usually talk in positives, we'll say 354th day. If you went backwards, you can just go December 20th. Would be the 354th day. What is the range of this function? What does the range represent? Okay, I'll finish up. You do the range. The range represents the minimum and maximum time of sunrise.
Just want to remind everyone that there is no student yoga after school today. And also,
So those are the answers to the questions. If you want to practice them, that's good. Practice the other two at home. So they're two really good questions. That's the type of style you're going to have to be able to do. Maybe we'll do them tomorrow.